Alright, so number one, let's start with part A. Find all equilibrium solutions. So an equilibrium solution is when dy dx is equal to 0. So we're going to set y squared minus 4 equal to 0. And what we can do is just factor it out. So y plus 2 and y minus 2. Which gives us y is equal to negative 2 and 2. So these are equilibrium solutions. And now we can just move on to part B. So draw the direction field. So in part B, we're going to take the equilibrium solutions and put it on a graph. So let's take y equals 2, draw it like this, and y equals negative 2. So y equals 2 and y equals negative 2. So now we need to draw the direction of the slope field. So we're going to look above y equals 2. Let's say y equals 3. And we're going to plug it into dy dx. So 3 plus 2 is positive, 3 minus 2 is also positive. So a positive times a positive gives you a positive. So our slope here at dy dx is positive. So we're going to draw a positive slope. And in between negative 2 and 2, there's 0. So we could use 0 as an example. So 0 plus 2 is positive, 0 minus 2 is negative, and negative times a positive is negative, so this is a negative slope field. And the same thing for the bottom. We could take negative 3 because negative 3 is less than negative 2. And we just plug it in here again. So negative 3 plus 2 is a negative, and negative 3 minus 2 is also a negative. So when you have a negative times a negative, it'll give you a positive. So a positive slope field. On to part C and D. Draw the solution curve through the point 3,5 and find the behavior of the solution. So the x-coordinate is kind of arbitrary in this case because we really just drew the y-coordinates. So like we know where y equals 2 is. So we're just really going to estimate where the y-coordinate is. So we can say the point 3,5 is around here. And we would need to draw a solution curve. And as you can tell, the solution above y equals 2 just goes on to infinity. So this solution curve is just going to infinity. So the limit as x approaches infinity of y of x at this point is infinity. Alright, so for part D, we're going to draw the solution curve through the point negative 4 and negative 1. So negative 4 is going to be on the left side of the graph, and negative 1 is going to be slightly above y equals negative 2. So we can say it's like around here. And now we need to follow the direction of the slope field. And in this case, it seems to be converging to y equals negative 2, because above and below, the curves are pointing towards negative 2. So we could just draw the solution curve like that. And the behavior of the solution would be the limit as x approaches infinity. So for part C, the limit was of y of x. The limit was just infinity for part C. And then for part D, the limit as x approaches infinity for y of x would be negative 2. Because they both converging to negative 2 as x approaches infinity. Like as all these points, as it goes on for infinity, it'd always go to negative 2. And that's number 1. Alright, so this is number 2. If you would like to pause the video and give it a shot yourself, go ahead. But I'll get started on number A right now, or letter A. Find all equilibrium solutions. So we're going to set minus y squared minus y equal to 0. We can factor out negative y. So we have y plus 1. And we have y equal to 0, negative 1. So now we draw the slope field. So we draw the graph. We could draw y equals 0 right here. And y equals negative 1 right here. So now we look above y equals 0. For example, we could say y equals 1. So once again, we plug in to the dy dx. So we do 1 plus 1 is 2, positive, and just plugging in negative 1. So negative 1 times a positive will give you a negative. So it's a negative slope field. And in between 0 and negative 1 is negative a half. So negative a half plus 1 is still positive, and negative a half times a negative is a positive. So positive times a positive will be a positive slope field. And finally, below negative 1, we could say negative 2. And if we plug in here again, so negative 2 plus 1 is a negative, and a negative 2 times a negative is a positive. So since we have a positive times a negative from here, that'll give you a negative. So this is a negative slope field. Now for part C, draw the solution curve through the point 1, 2, and find the behavior of the solution. So the behavior would be the limit. But first, let's draw the solution curve. So 1, 2, we would have to look where y equals 2. We know y equals 0 at this point here. So we would say y equals 2 is like around here probably. And the x-coordinate is 1, so it's on the right side of the graph. And at y equals 0, it seems to be that it's converging. So all of these points converge to y equals 0. Sorry if my arrows are a bit scuffed. This is not a great pen. So for part C, we say for the behavior of the solution, limit as x approaches infinity for y of x would be 0. And for D, draw it through the point 2, negative 3. So 2 would be on the right side of the graph, 3 would be below negative, well, negative 3 would be below negative 1. So it would be around here. And this just goes on to negative infinity. Oh, it's also important to label the point. So 2, negative 3. And over here was 1, 2. So we say limit, to describe the behavior of the solution, limit of y of x as x approaches infinity would be negative infinity. Because all of these points, as you keep going, as x increases, it's just going to go to negative infinity. Alright, so this is number 3. It's a bit different. It's asking find the differential equation of the form dy dx is equal to ay plus b, whose solutions are a, diverging from y equals negative 1/2, and b, converging to y equals 3. So first let's do part A. Part A says that the solutions are diverging from y equals negative 1/2. So all we need to do is graph y equals negative 1/2. And since it's saying that the solutions are diverging, they're all going to infinity from 1/2. So it would look like this. So these solutions are all diverging from negative 1/2. So now we can establish that dy dx is greater than 0 when y is greater than negative 1/2. And we get that by looking at the slopes. So here, since the slope is positive, since it's going to infinity, dy dx is going to be greater than 0, and this is above negative 1/2. So we could rearrange this to be 2y is greater than negative 1, and then 2y plus 1 would be greater than 0. And so since dy dx is also greater than 0, we can just say dy dx is equal to 2y plus 1. So a is 2. So a is 2, and b is 1. So for part B, it's saying that it's converging to y equals 3. So once again, we just draw at y equals 3. And the solutions would look like this. They would be pointing towards y equals 3. So if we look above or bottom, this time let's look at the bottom, because why not? So below y equals 3, we can notice that the slope is greater than 0, because it's positive slope here. And it's below y equals 3, so when y is less than 3. So we could rearrange this to be y minus 3 is less than 0. And we want to flip the sign since we're using dy dx is greater than 0. So when we flip it, we need to make it negative. So negative y plus 3 is greater than 0. So your dy dx is equal to negative y plus 3, and therefore a is negative 1 and b is 3. So this is the final problem, number 4. It's just asking you find the differential equation. So how about you pause this and give it a try yourself. Alright, so once you give it a shot, you could now continue the video. So here we're just given the slope field. But if you notice that the solutions are all pointing towards 1/3, so we can say it's converging to 1/3. But more importantly, we can say below 1/3, so when y is less than 1/3, over here, that's supposed to be an arrow, these solutions are all positive. So we say dy dx is greater than 0. So we take y less than 1/3, we say 3y is less than 1, then we move over the 1. And now, once again, we had to flip the sign because we're using dy dx is greater than 0. So we're going to make this negative. So now they're both greater than 0, this one and this one. So now we can just say dy dx equal to minus 3y plus 1, and that's your differential equation.